Okay, the division is simply the inverse of the multiplication. So instead, we build again our two columns, but in this case, we look in the second column. We take the first example, 125 divided by 5. In the second column, we stop when the numbers become bigger than the dividend. That's one thing. And in the second column, remember, in the multiplication, we were looking in the first column. Now it's the inverse in the division, so we look in the second column. So first thing, we stop when the number in the second column becomes bigger than the dividend, which is 125 in this case. And then we try to look in the second column for the numbers when added up form the dividend. Clearly, 80 plus 40 plus 5 equal 25, equal 125, which is the dividend. And we look at the numbers in front of them in the first column. So 1, 8, and 16, we add them up, we get our quotient, 25 indeed. Similarly, second example, 840 divided by 24. We remember from the multiplication that it should give 35. We repeat the same thing, build our two columns, 124, 248, etc., etc. Now we stop when the numbers in the second column become bigger than the dividend. So we stop at 768 because if we multiply by 2, 1,836 is bigger than 840. And again, we look how we can form the 840 from the numbers in the second column. It is a little bit more difficult than the multiplication, but still fairly easy. And we can see that 768 plus 48 plus 24 is exactly equal to 840. So we look at the numbers in front of them in the first column. In front of 24 we have 1, in front of 48 we have 2, and in front of 768 we have 32. We add this up, and voila, the quotient is 35 as we have expected. So far we have talked about exact divisions, or divisions where there is no remainder. The remainder is 0. So what if the remainder is not 0? Okay, so if we have a division with a remainder, we will look at a very simple example. We'll take 11 divided by 4. We build our two columns as usual, very small, short columns. We'll have 1 and 2 in the first column and 4 and 8 in the second column, and we stop here because if we double the 8 we would have 16, which is bigger than the dividend, which is 11. So now we cannot form an exact 11 from the 4 and 8 because 4 plus 8 is 12, and this is bigger than 11, so we don't do that. So we have 4 or 8, both are smaller than 11, but 8 is closer to 11 than 4. So we circle the 8, and we look at the number in front of it in the first row, which is 2, and this will be our quotient. So the quotient is 2. Now, how do we know the remainder? Very simple, like what as we do today. 11 minus 8, that gives us the remainder. So the remainder is 3. So the ancient Egyptian will know that he has 2 and 3/4, but the ancient Egyptians did not write fractions in the form of 2 over something or 3 over something, etc. They always wrote their fractions as a sum of unitary fractions, like 1/2 plus 1/4. That would be 3/4. or 5 over 8, they would write it as 1 over 2 plus 1 over 8, and so on. So for an ancient Egyptian, the result would be 2 plus 1 over 2 plus 1 over 4, or 2 plus half plus 1 quarter. The reason the Egyptians did that was probably that it suited their needs better. They used the arithmetic most often in shops, or to calculate the product of crops in land or things like that. So in a shop, for example, if 4 people come and say we want 11 loaves of bread, how would he divide those 11 loaves? Okay, if we write 2 plus 3 quarters, he will give each one 2. And then what will he do with the other ones? Will he divide each one in 4 quarters and give 3 from those quarters to his clients? That could be, but you'll find that it is easier actually to know that he should give 2 loaves plus 1 half loaf plus 1 quarter loaf to each one. In this way, he will not have to divide the 3 remaining loaves, each one into 4 equal pieces. He will have to divide only 1 into 4 pieces and the other 2 into halves. So he will need to do less work this way. Okay, so that concludes our presentation. I hope you have enjoyed it, and hopefully we will see each other soon in another video on the arithmetic in ancient Egypt. Bye-bye.